I'm Anil Kumar. Welcome to my series on complex numbers. Here in review, part 3, we have 8 multiple choice questions on complex numbers. These questions can help you in many competitive exams, including SAT. I'd like you to look into these 8 questions, answer them, and then check with my solution. Here is question number 1, where we are looking for the value of I to the power of minus 23, where I square, the imaginary part, is minus 1. The question number 2 is to evaluate I to the power of 38. So these are related, but we will give you good practice. Question number 3, evaluate minus 4 times minus 9. Question number 4. We are given two complex numbers, 2 minus 3i and 4 minus 7i. You need to find their difference. And then write the value of a minus b. Question 5. If w equals to 12 minus 5i, where I square is minus 1, find w square. In this case, we have if w equals to 12 minus 5i, where I square equals to minus 1, find reciprocal of w, that is 1 over w, right? Question number 7. Now we have quotient of two complex number, 2 minus 3i and 4 minus 3i, which should be equal to a plus bi, where square root of I is minus 1. Find the value of a. The last question here is, square root of 3 minus 4i is a plus bi, where square root of I is minus 1. Find the non-negative value of a. So these are the 8 questions for you. Take your time, solve them. You should be in a position to solve these questions in less than 12 minutes. So if you can't, look into my review, part 1, practice, and then get back to this exercise. Now let's see how to solve them one by one. Question number 1. Evaluate I to the power of minus 23, where I square equals to minus 1. Now in our previous videos, we have told you a strategy, which I am going to show you once again here. However, I'll teach you a new method to find the solution. So if this is the imaginary axis, that is the real axis, right? So this is the imaginary axis, and this is the real axis. In that case, we can write I here, right? So this is minus 1, this is minus I, and that is plus 1, correct? That is how it is. So as we increase the powers of I, we know it could have a value which could be I minus 1 minus I or 1. So that multiplication goes in this kind of format. Now it is important to understand that when I square is minus 1, then I to the power of 4 is equal to 1, right? So this is I to the power of 4, I to the power of all multiples of 4, right? Which is 1. Now I'm looking for I to the power of minus 23. Think like this. It is 1 over I to the power of 23. Now 1 could be written as I to the power of 24, right? A multiple of 4. And we have I to the power of 23. Clearly 23 take away from 24 gives you the value of I. Do you see that part? And so the option is C. So in your multiple choice question, I like you to practice with this approach for especially negative exponents, right? So you could write this as 1 over I to the power 23. 1 could be written as I to the power of multiple of 4, right? Closest to the one given to you, 24 in this case, and then you get your answer straight away. So I hope that helps. Question number 2. Evaluate I to the power of 38. So in that case, what do? I to the power of 38, it is like I to the power of 36 is 1, right? Since I square is this, we know I to the power of 4 is 1. I to the power of 36 is going to be 1, right? So we could divide this by 1, and what do we get? we get I square, and we know I square is minus 1, so the answer is B. So this is a very effective approach which can be adopted. It's absolutely new approach for the new SAT students. So those who are going to use this approach are going to save a lot of time. So we had two questions with powers of I. Now let us see. Square root of minus 4 times square root of minus 9. Now you cannot really multiply them, right? Because they are not real numbers. So in this case, whenever you have square root of minus 4 times square root of minus 9, square root of minus 4 is 2i, right? So you're multiplying this by 3i. So what do you get? You get 6i square, and I square is negative, so you get minus 6 as your answer. So it is minus 6. So it is a bit tricky question, right? However, with the clear-cut concepts, I think you cannot make a mistake here. Question number 4 is subtract two complex numbers. So basically, we are doing 2 minus 4, and we have minus 3i. And this becomes minus and minus is plus 7i, right? So like terms. So we get minus 2 plus 4i. We need to find what a minus b is, right? So a in our case is minus 2, right? So a is minus 2 for us. So we'll do minus 2 minus b is 4, which gives us minus 6. So b is the right answer. Perfect. So that is how you're going to answer this question. So till now, I think there are no problems. Now let's get into slightly difficult level. These are all without calculators. So now the questions which we are getting into are rated from around question number 15, right? So they're pretty high rated, above 12, right? For sure. Now here we have a complex number, 12 minus 5i, where I square is minus 1. We need to find what w square is. So w square, 12 minus 5i. Let's see how to multiply them, right? So square will be a square, which is 144, minus 2 times ab, so 2 times 12, times 5i, plus b square, which is 5i square. Purposely I'm writing like this. So 144. Now here we get 10 times 12 as 120i, and that gives you plus 25i square. Remember, I square is negative, right? So these two are the real parts. So basically we get 144 minus 120i minus 25, correct? So this can now be combined with 144. So you get 119 minus 120i as a result. So which is option B for you. So it is necessary for me to show you all the steps so that you understand how we are getting the right answer. However, it should not take more than a minute. Question number 6. W equals to 12 minus 5i, where I square is minus 1. So remember, sometimes we write square root of I equals to, square root of minus 1 equals to I, and sometimes we write I square as minus 1. So either way, it could be given to you. We need to find reciprocal of W. Reciprocal means 1 over 12 minus 5i, correct? This is what we need to find. So in this case, we have to multiply and divide by its conjugate. So we get 12 plus 5i. So we have already seen how to multiply, right? Now, so in the numerator, we have 12 plus 5i. In the denominator, we get a square minus b square. So we get 12 square minus 5i square. So we get 12 plus 5i, and in the denominator is 144, and I square is negative, right? So we get plus 25. So the denominator is 169, and the numerator is 12 plus 5i. So the answer is A for us, correct? So that is how we could solve it very easily. Question number 7. 2 minus 3i divided by 4 minus 3i equals to a plus bi, where square root of I equals to minus 1. Find a. So we need to find the value of a. we are given 2 minus 3i over 4 minus 3i. So we need to rationalize this. We'll just multiply by 4 plus 3i over 4 plus 3i. So that gives you, in the denominator, we have 4 square, which is 16, minus 3i square, right? In the numerator, 2 times 4 is 8, 2 times 3 is 6, 6i. Multiplying by minus 3 gives us 12i minus and minus 9i square. Now that gives you 8 plus 6i minus 12i, and that becomes plus 9 since I square is negative 1. Denominator also, we get 16 plus 3 square as 9. Now we can add the like terms. 8 plus 9 is 17, and that is minus 6i divided by 25. We need to find the value of a, which indeed is 17 over 25, right? Minus 6 over 25i is the answer. So the value of a basically is 7 over 25, the real part. So option A is the right option. So I hope that is absolutely clear. Let's move on and take the last question now, which is question number 8. If square root of 3 minus 4i equals to a plus bi, where square root of I equals to minus 1, find the non-negative value of a. So we are given square root of 3 minus 4i equals to a plus bi. Let us square both sides. We get 3 minus 4i equals to a plus bi whole square. Now that could be written as a square plus 2abi plus bi square, correct? Now bi square is negative b square since I square is minus 1. So this also means that I've written it wrong. Square root of minus 1. I square is minus 1 and square root of minus 1 is equal to y, correct? So that is a correction. Okay, so we could write this as 3 minus 4i equals to a square plus 2abi minus b square, right? So as you can see here, we have a real part which is a square minus b square, and we have imaginary part which is 2abi. Comparing real and imaginary parts, what do we get? We get the imaginary part is 2ab, which is equal to minus 4, right? From here, since we need to find the value of a, we can write b in terms of a, right? So b equals to minus 4 over 2a, or we can say b equals to minus 2 over a, correct? Now let us see what is the real part given to us, which is a square minus b square. So we get a square minus b square, that should be equal to 3. Replacing b with minus 2 over a, we get a square minus 2 over a whole square equals to 3, or a square minus 4 over a square equals to 3. So let's multiply all the three terms with a square. So we get a to the power of 4 minus 4 equals to 3a square. Bringing them together gives us an quadratic equation which can be factored and solved. So we're looking for a product of minus 4, sum of minus 3. So we can have this as a square minus 4 times a square plus 1 equals to 0. Now that gives us two answers for a, which is a equals to plus minus 2. Here there is no solution since a and b are real numbers, right? So a is plus minus 2. We are looking for non-negative value of a. So therefore option B is the right option. Perfect. So that is how we can actually solve all these questions. With this practice, you should be in a position to answer most of the questions related to complex numbers in multiple choice tests. I hope that helps. Feel free to write your comments, share your views, share your questions so that we can address them directly. Feel free to write comments and share my videos with your friends. Thanks and all the best.